This set of notes covers the properties of logarithms, but first let's start with a bell ringer review. Number 1 says to rewrite in exponential form. So we have log base 3 of 9 is equal to 2. If we want to write it in exponential form, remember I said if you're ever stuck, always start with your base. Your base is 3. You can't write these side by side, so you would use the 2. So it's 3 squared is equal to 9, which is a true statement, so that's a good sign. Again, start with your base of 1/2. Don't write these side by side, so that leaves the -4. So 1/2 to the power of -4 is equal to 16. You might even want to put the 1/2 in parentheses. Also a true statement, so that's a good sign. Number 2, you're rewriting in logarithmic form. So we're going in reverse pretty much. So I have log, you need your base. The base is 125. Of, same idea, you're not going to write these side by side, so that only leaves the 25, which means it has to equal the 2/3. This one would be log, I have a base of 5. Don't write these side by side, so that leaves the 1/25 is equal to the only thing that's left, which is the -2. And finally, number 3, when they want you to evaluate, they want to know what this is equal to. I like to set it equal to x because then it helps me set up my equation. Again, if you're lost, start with your base. My base is 3, so I'd have 3 to the power of x is equal to 81. The base is your hint. If this is a base of 3, I want to rewrite 81 with a base of 3. So you could just do in your calculator, like 3 to what power gives you 81, and it's 3 to the 4th power. Since the bases match, that means x has to equal 4. So log base 3 of 81 is equal to 4. Same idea for this one, set it equal to x, start with your base. So I'd have 5 to the power of x is equal to 1/625. Let me just bump that up a little bit. I have a hint with this base. If that is a power of 5, I want to know what power of 5 is going to give me 1/625. I know that 5 to the 4th power is 625. So since I want the fraction, I would just do 5 to the -4th power. So negative powers are fractions, which means x is just equal to -4. So we're getting into properties of logarithms. These are the ones that we use the most often, the product property. If you have a log with a base b and you have m times n, instead of multiplying m times n, you can break it down into addition. I like to think, if you remember our old school multiplication used to be like a little baby multiplication sign. If you think of your little baby multiplication sign, it kind of rolls over into a plus sign. Some people like to, think of cheesy things to help them remember stuff like this. So if you think of m times m, like that little time sign, and it rolls over into a plus, you can write it as log base b of m plus log base b of n. So notice it's still the same base. It's just instead of multiplication, you can change it to addition. You have the quotient property where if you're dividing log base b of m divided by n, instead of division, you can change it to subtraction of log base b of m minus log base b of n. So for this one, you can think of this division bar as a subtraction sign. I'm actually going to write that down. Think of division bar as subtraction sign. So a lot of times you'll see me trace that. So hopefully that'll make you think, oh, that division bar can change to that subtraction sign. And the power property, if you have log base b of m to a certain power, basically this power just moves to the front. You can see it right here. So power moves to front. So using those properties, they want us to use log base 2 of 3, which they're telling us is approximately equal to this decimal, and log base 2 of 7, which is approximately equal to this decimal, and evaluate each logarithm. So just think we have a 3 and a 7 as part of our logs. So here, if I have log base 2 of 3 over 7, hopefully you catch on that since this is division, that little division bar sign reminds you of a subtraction sign. You can change this to log base 2 of, it is important that whatever's on the numerator you write first. So log base 2 of 3, this becomes a subtraction sign, minus log base 2 of 7. Now log base 2 of 3 was approximately equal to 1.585. Minus log base 2 of 7 was about that 2.807. You type that in your calculator and you get negative 1.222. Here I have log base 2 of 21. If I need a 21 and I have a 3 and a 7, I can get a 21 if I multiply 3 and 7. So I would think of log base 2 of 21 as log base 2 of, instead of 21, I would think of it as 3 times 7, because 3 times 7 is 21. But since it's multiplication, I can change it to addition. So think of that little time sign change into a plus sign instead. So I'd have log base 2 of 3 plus log base 2 of 7. Log base 2 of 3 is that 1.585. Plus log base 2 of 7 is the 2.807. You add them together and you get 4.392. And log base 2 of 49, when I see 49, I think of it as 7 squared. So I would look at it as log base 2 of 7 squared. And I know since it's squared, the power can move to the front. So it'd be 2 times log base 2 of 7. But log base 2 of 7 is equal to 2.807. 2.807. So 2 times 2.807 would give me 5.614. I might actually just put that in parentheses because it looks a little weird since I have 2.807 and then I had that as my multiplication sign. Kind of looked like a double decimal. So just put that in parentheses to make it easier to see. Don't forget, since this is a video, at any time if you need to pause or rewind, feel free. This one just wants me to expand, so just be careful because order is important. The first thing I am able to do, and even though I should mention it's a natural log, I can still use all the same properties. They all still apply. So natural log, I'm still able to use the same properties. The first thing I'm able to do, hopefully you see that since it's division, I'm going to change that to subtraction. So natural log, that's my cursive L, don't forget, natural log of 5x to the 7th minus natural log of y. Now, a silly mistake that people make here, they want to take this power and move it to the front, but I cannot take this power and move it to the front because this power only applies to the x. If this 5x was in parentheses and the 7 applied to the whole grouping, I could move it to the front, but since it only applies to the x, I cannot move it into the front yet. However, I do have natural log of 5 times x to the 7th. So since this is multiplication, I can change that to addition. So it would be natural log of 5 plus natural log of x to the 7th minus natural log of y. And now I can move this power to the front. So I would have natural log of 5 plus 7 natural log of x minus natural log of y. And that is fully expanded. This one wants me to condense. So I have log 9 plus 3 log 2 minus log 3. The first thing I have to do is take care of this power. Well, the number in front will become my power, I should say. So I'm going to have log 9 plus, that becomes a power, so it'll be a log 2 cubed. I can do that math in a second. Next thing I notice is that I can change addition to multiplication. So that'll just become 1 log, and then it will be 9 times 2 cubed. I'll do all my math at once. And then I notice that subtraction is going to become division. So this is just going to be log of 9 times 2 cubed divided by 3. Now I'll do my math. 9 times 2 cubed is 72. And 72 divided by 3 is 24. So I get log 24. Next one, they want me to expand. So again, just be careful, because some people, will try to like move this power to the front, but you can't, because this power of 4 only goes to the x. So the only thing I can do at the moment is I notice that they are multiplying, so I can change multiplication to addition. So I have log base 6 of 3 plus log base 6 of x to the 4th. And now I can move this power to the front. So I have log base 6 of 3 plus 4 log base 6 of x. That's all I can do with that one. And then another one where they want us to condense, but it's with natural logs. I'm going to have to start by making this 3 a power. So I have the natural log of 4 plus the natural log of 3 cubed minus the natural log of 12. Next step, I notice that I'm adding. So I like to think of that, if I just rotated it a little bit, it looked like a multiplication sign, so I can change addition to multiplication. So that'd be natural log of 4 times 3 cubed. And then I can change subtraction to division. So this will be the natural log of 4 times 3 cubed divided by 12, and then you just tidy it up. 4 times 3 cubed is 108. And then when you divide that by 12, you get the natural log of 9. Now I told you that when we used our calculators to type values in for logs, that our calculator only had the log base 10, but that there was a way we could type in ones like this that had a different base than 10, and this is the way we do it. We use this change of base formula. So if you have something that is a different base other than 10, all you do is basically you just take it, this is the easier way to look at it. If you have this set up, it's going to be log of the big number divided by log of the base. And you can also do it with natural log. So if I have this set up, I could do the natural log of the big number divided by the natural log of the base. So if they want me to evaluate this using common logs, and then this one's with natural logs, so you can see both setups, by the way. So evaluate using common logs. So again, I couldn't just use the log button on my calculator and type that in straight away, because the calculator log button has a base 10. But what I could do is I could type it in like this. So I have log base 3 of 8. I would have to type it in as log 8 divided by log 3. These will have the same value. And notice now this is a base 10, so I can use the calculator button. And when you type that in, you should get somewhere around 1.893. So you should make sure you type that in so you can get that value. And the log button is, I think it's by the 7, the number 7. And you could also do the same thing with natural logs. So if I have log base 6 of 24, let's say for some reason your log button just wasn't working, you could instead type in natural log, it's always the big number first, natural log of 24 divided by natural log of 6. So you could use either way, you'll still get the same correct answer. This one should be about 1.774. So make sure you can type those in and you're getting the correct answer. This question wants to know which of the following is not equivalent to this log setup. It says justify your answer. So I'm going to just actually go ahead and write this off to the side, do all the math, and then we'll see which one doesn't work. It'll be good practice that way. So if you wanted to pause the video, try it on your own, and then you can just fast forward, see if you got it right or not. Probably be a good idea. You could do that with any point throughout the video. Let's see, the very first thing I notice, and hopefully you as well, is that since it is division, I can change it to subtraction. So I'm going to have log base 5 of y to the 4th minus log base 5 of 3x. Next thing I see is that this power can move to the front. So I have 4 log base 5 of y. And at the same time, I'm going to kind of multitask here. I notice that this is times. So I am going to change this to addition, but here's where silly mistakes are made, because it's minus this whole quantity. So when I change this to addition, I'm going to have to make sure I do minus this whole quantity. So it'd be minus, I'm going to put in parentheses, because it'd be log base 5 of 3 plus log base 5 of x. But you see how it's still minus that whole quantity, just like it was in the previous step? So I do need to distribute that subtraction sign, and I guarantee that's probably where this error is, the one that's not equivalent. But let's just keep going for now. 4 log base 5 of y, distribute, I get minus log base 5 of 3 minus log base 5 of x. I'm just going to look for it, because look, it's right here. That one's wrong, because they forgot to distribute the negative sign. You can see that coming a mile away. So just watch for stuff like that when you have, when you're subtracting a quantity and you break that, you know, if you break it apart, that subtraction sign applies to everything after it. So you have to distribute, you have to be careful. This one says, use a graph to determine the value of log 8 over log 2. This is what we did on the previous page, how we kind of broke it down. This came from log, remember this is the base, think bottom base if that helps you. So this came from that, and this is where the graph came from. So there's the 2, this would be 8. So they're saying x is 8, so if x is 8, they're looking at this value right here, which goes with, if that's 2 and that's 4, that would be 3. So it's equal to 3. So this is that previous property on the previous page. You have to know that this is stemming from this. That was the formula they were using. So that 8 is representing the x, or x is representing the 8. If you go to 8, it lines up with the 3, so it's equivalent to 3. Just some more practice on simplifying, it looks like. For this one, there's nothing in front, so I can't do anything with powers, but I do see addition, which I know I can change to multiplication. So I would have log of 4 times 25, which would give me a log of 100. Now, it does say simplify, so I'm going to simplify it as much as I can. This would technically have a base of 10, and if I set that equal to x, I would have, if I rewrote this, I start with my base, 10 to the power of x equals 100. I know that 100 is 10 squared, so that x equals 2. So all of that would equal 2. Kind of interesting. So apparently log 4 plus log 25 is 2. All right, this one looks a little weird. Now don't try to say these match so something drops down. I can't do that part yet. I'm gonna have to combine this first. And as I look at it, hopefully you notice that with the subtraction, you're starting to think, okay, subtraction, I can change that to division. So I have 3 to the power of log base 3, and I'm gonna change that to, instead of subtraction, it would be 4 divided by 8. I can simplify that. Instead of 4 divided by 8, that would reduce down to 1/2. And now you can do the part where these bases match, so they undo each other and the 1/2 drops down. What do we got here? Let's see. All right, if I'm simplifying this, this could be rewritten as a power. So 2 to the power of log base 2 of 5 cubed. I know that 5 cubed is 125. I see that these bases match, so they undo each other, so I just get 125. Not too bad. So suppose that log base b of u equals 2, log base b of v equals 3. Use properties of logarithms to simplify. Okay, so here we have one where we're multiplying, so we can change multiplication to addition. Again, this is one where I'd probably pause it, try them all yourselves, and then unpause it, see if you get them right, and if not, then watch only the ones you miss. But that's your call, what you want to do. So again, since this is multiplication, I'm going to change it to addition. So it'd be log base b of u plus log base b of v. Well, log base b of u is 2, and log base b of v is 3, and 2 plus 3 is 5. Okay. This one is division, so I can change that to subtraction. It is important that you write what's on your numerator first. So it'd be log base b of u minus log base b of v. It's kind of a tongue twister. Log base b of u is 2 minus log base b of v is 3. I get a -1. Same thing, it's just order is important because v this time is on my numerator, so that will go first. So log base b of v minus log base b of u. So this time I will get 3 minus 2, which is 1. All right, these ones are a little bit more involved. Let's see what's happening here. First and foremost, I am multiplying, so I'm going to change it to addition. So I'd have log base b of u to the 4th plus log base b of v cubed. Next, I can move both of these powers to the front. So it looks like I have 4 times log base b of u plus 3 times log base b of v. I'm going to try to squeeze this underneath. So it'd be 4 times log base b of u, that's 2, plus 3 times log base v of v, which is 3. That would be 8 plus 9, which is